recording now, so you can check that out later. Anyone who's watching live, welcome. We're dealing with some honors geo right now, and we're talking about the Unit 4 review. Riker, did you share that Jamboard with me yet?
Yes, I did.
Which one is it?
See. Let me
Is it
label
the old one? Is it the one from back November 5th? You sure you shared it with me?
Yeah.
napervilletutor@gmail.com. Check to make sure you spelled it all right, because I don't see it here. This is my shared with me.
Here, I'll send it again. See if you get it this time. Should be Unit 4 review.
Got it. Okay. I'm just going to run through them, okay?
Okay.
All right. So are they want us to do proofs here?
Yeah.
Okay. So given that 1 and 5 are congruent, 1 and 5 are congruent, 2 and 6 are congruent, prove that ABC is an isosceles triangle. Okay. Do we know anything else is parallel or anything like that?
No.
Well, I guess we do know they're parallel, because so the first thing we're going to do, I'm just going to talk them through, okay?
Okay.
And then if you want to go back through and actually write them up, practice writing them up, we can, but you can watch the video again. So do you see how the fact that these are alternate, no, corresponding, out there, corresponding? Yep. If you were to draw these lines in, if you were to extend these lines out like this, do you see how this transversal right here, hold on, let me do a better job drawing this. I don't know why I didn't draw this transversal right here.
Yep.
Shoot, no, that's not true.
Oh yeah, because one would have to be corresponding to angle 4.
Yeah, those are not corresponding. So we do not know that those are parallel. So sorry. Trying to think through what we do know. It seems like that would have been parallel, right?
Yeah.
But we can't assume that they're parallel. They didn't tell us that it was parallel.
Yeah.
Okay. So what do we know? They want us to prove that ABC is, so they basically want us to show that, I'm way overthinking this. Okay. You can assume straight lines. So that you can assume is 180 degrees, right? And yes. Same with this. So we can use by the, let's see, I think it's going to be the subtraction property.
Can't we just assume straight angles?
Yeah, we are assuming these angles are straight.
Yeah.
And so since what you can say is that angle 1, 2, 3, the sum of those three is equal to angle 4, 5, 6. I think maybe you'd say it like that.
Okay.
And you can say straight angles. All straight angles are equal, or both equal 180 degrees. I'm not sure which property you'd want to use for that.
Yeah.
And then you would say angle 3 equals angle 4, and you would use the subtraction property, because you're subtracting the same two things from that same equal angle.
Okay.
Do you get what I'm saying? So subtraction property. And then now that you have 3 and 4 are equal, now you can say ABC is isosceles, and you can use and say by the definition of isosceles.
But I can't use the definition of isosceles. So I would, since I have 3 and 4, I would have to use if angled then sides to say that it's isosceles.
Oh, your definition of isosceles is that the sides are equal?
Yes.
Got it. Okay. I thought that you would have been able to show that you could use angles or sides, but you are correct then. Then you would want to say if angles, then sides, and then you can say the definition of isosceles triangle. Yeah. Because if your definition of isosceles is that you have two equal sides, then yeah, you need the sides.
Okay.
We know that it's actually also could be two equal angles, but if you don't have that given to you, or if you haven't proved that yet, or you haven't been allowed to use that yet, then yeah, you can. Okay, sound good?
Yep.
14, it says given, I'm going to move these around because this is, to me, it's backward. Okay. Given that AB
It's congruent.
equals, yeah, it's congruent to AF. Okay, I see that. Let me draw that a little bit better. And BD is congruent to, okay, you've drawn those in. Good job. Angle 1 and angle 2 are equal to each other. So that's this and this. Prove that C is congruent to E. So they want us to prove that this is congruent to this. We don't know that yet. I'm drawing it in white to show that's what we want to prove. Okay. So let's come up with a plan here. I can immediately see, can you see that this triangle, this angle right here, or this triangle, I can show that so this would be a detour proof. See how that side right there is shared by both of these triangles here?
So I would use the reflexive property to say
You
that.
could use the reflexive property, and then you would have side, side, side. This is congruent to this, right? Triangle Roman numeral 1, let's say, is congruent to triangle Roman numeral 2. You can name them correctly, but you get what I'm saying. And then because of that, okay, good. I'm going to erase these so we don't get confused by that. Because of that, we can say then that these angles are equal to each other. CPCTC, that angle and that angle, are equal to each other. Got it?
Yep.
And then by the subtraction property, we can show that this angle is equal to this angle. Or I don't know if you want to use subtraction or supplementary. There's that one supplementary, I think, theorem that you had. Like, supplementary angles to congruent angles are congruent or something like that.
Something like
right?
that, yeah.
You can use that, or you can use the subtraction property. In fact, for this last one, you could have used that as well. You could have used the supplementary. You could have said angle 1 plus 2 equals angle 5 plus 6, right? And you can name, I don't know, you want to name them again, but, and then you could use the supplementary thing. 3 and 4 are supplements to those angles. I don't know if that would have been an easier way to state it, but be careful how you're stating these things. I feel like you're pretty good at doing that. But now that we have that angle, what can I use to show that these two triangles are equal to each other?
We could use ASA.
Angle, side, angle, exactly. And since we have angle, side, angle to show that these two triangles are congruent, now we can use CPCTC to show that this angle is equal to that angle.
Okay.
Make sense? So we took a detour. We first proved that these two triangles were equal to each other. Then we showed CPCTC that those angles are equal. Then we used that to show that those angles are equal, that supplementary thing, which allowed us to prove these triangles are now congruent, which allowed us to prove that those angles, CPCTC, are congruent. So that was a relatively long proof. Got it?
Yep.
All right, the next one, given the angle O, NK, and CK are congruent to each other. So you've labeled that, good job. Now, you've also put this in there, but they didn't tell us that, right? You're going to state that.
I labeled that because all radii are congruent.
Good. So that's the first thing you're going to do is state that those are congruent because they're radii and all radii are congruent. Let's
Mhm.
see. KO is the perpendicular bisector of NC. So in order for that to be the perpendicular bisector, you need to show that it is a right angle and
You
that
show
these
that.
two things are equal to each other, right? And you're going to show it's a right angle by basically proving either that this is equal to this or that this one is equal to this one, because then CPTC will show that these two angles are equal. And then do you have a property that you utilize that states that if two angles are equal to each other and supplementary, then they are right angles? Do you have
No,
something like that?
I have a theorem that says if 2 points are each equidistant from the endpoints of a seg, then the 2 points determine the perpendicular bisector of that seg.
Oh, okay. Say it one more time. If 2 points are
If 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment.
okay, if 2 points are equidistant from the
The
end
endpoints.
point of a segment,
Mhm.
2 points are equidistant from the end point of a segment. So this and this, no, those aren't equidistant.
No, it would
So
be
zero is
ON,
equid.
ON and
Okay,
OC.
ON and OC are equidistant from the endpoints of this segment.
Yeah.
Say it one more time. I'm trying to visualize what this is saying. If 2 points are
Are each
equidistant,
from the endpoints of a segment, then the two
okay,
points.
stop there. If 2 points are equidistant from the endpoint of a segment, so are we talking about this segment and the 2 points being N and C? Or are we talking about this segment and the endpoints being K and O?
I think because we're trying to determine the perpendicular bisector, that it would be N and C. So, which we would need
Probably do
O,
either one.
yeah, which is why we would need O
Well,
and O.
no, that's not true. You can't do either one because this is not a perpendicular bisector of KO. This one is a perpendicular bisector of NC.
Mm-hmm. So it would be NC, and then it would be OR, right? Those would be the two segments.
I'm still trying to I'm trying to make sense out of what the theorem says. If 2 points are equidistant from the endpoints
Of a
of a
segment.
segment, so
So for this one, what I
two
would do
points.
is, since I know that the two segments are like congruent, ON and OC, and I know
Mm-hmm.
that NK and C and KC are congruent, then I would be able to use that theorem, because it would be okay. That's the perpendicular bisector, and it goes straight through NC. So that's what I would use to solve that one.
I guess I read that one more time.
If
Read the
two
theorem one more
points,
time.
if 2 points are each equidistant from the
Each
endpoint, yep, each
equidistant
from the endpoints
from the endpoints
of a segment,
of a segment,
then the 2 points determine the perpendicular bisector.
of that segment.
Yep.
Okay. If 2 points are equidistant from this is the part I'm trying to understand what the definition is. Equidistant from the endpoints of a segment.
Mm-hmm.
Equidistant from the endpoints. If 2 points are equidistant from the endpoints of a segment. So the n is equidistant from that those things are the same and these
Mm-hmm.
things are the same.
Yeah.
That means that
OK would be a perpendicular bisector.
again, I'm not seeing this. If 2 points are each equidistant from the endpoints of a segment, see, they want OK. O and K are equidistant from, O is equidistant from N and equidistant from C, or
Mm-hmm.
O and C, and K is equidistant from K and N. But couldn't you also say that about N and C? Oh, no, it's not. It's not equidistant. Okay, I understand that now. I understand what it's saying. Yes,
Mm-hmm.
that is correct that you can use that one. That's a much easier. I was basically
'Cause
trying
then
to
it would,
prove that.
yeah, then it would be like a 3 or 4 step proof instead of
Right,
being a 7 or 8.
exactly. Yep. And that's why I always ask you, well, do you have this yet? Did they teach you this yet? Can you use this property? Remember when we talked about that with unit 3.7 with the if angles then sides? And you're
Mm-hmm.
like, no, we haven't learned that yet. I'm like, well, this problem is from 4.1. I think they expect you to use that. And we're like, well, we can't use it. Okay. Well, we're gonna have to figure out a different way to prove it then, which is
Yeah.
basically is reestablishing that whole thing. So yeah, that is the correct way to do it, what you just did there. Yes. Sorry for taking so much longer
Mm-hmm.
to
And then
comprehend that, but
I think these ones are all algebra, so we should go through them a little faster.
okay, find the coordinates of G. So endpoints, the way endpoints work. Hold on one second. My wife got home. I'm gonna have to go in the other room. Okay. So find the coordinates of G. So what do you know about if M is the center? What do you know about what do you know about F FM and GM?
They're congruent.
Good. So how can you find FM? What do you use
FM.
to find FM?
We could
Oh,
use.
actually, no, there's an easier way. You don't even have to do that. You know that M is going to be the midpoint, right?
Mm-hmm.
So you'd want to use the midpoint formula. So let's call this A and that B,
Okay.
or you could say X and Y, I guess. Duh. Let's go X and Y, because that's usually what we do. So if that's X and Y,
Mm-hmm.
then you know the midpoint formula says that -7 plus whatever X is divided by 2 and -3 plus whatever Y is divided by 2 is going to give you your midpoint. And your midpoint is M in this case, right? So this equals -4 and this equals +5, right?
But if we don't know what X is, how do we get that?
Well, now we solve this equation. Am I doing the right midpoint formula? Is it the two things added together divided by 2? Or is it subtracted? Let's see. I always, to remember, I always do this. Like between 1 and 3, what's the midpoint between 1 and 3?
2.
2. So you do 3 plus 1, and then you divide that by 2.
That equals 2.
Okay. So the midpoint theorem is you add the two values together. which is what I did there. So that plus whatever x is, and you divide it by 2. That plus whatever y is, and you divide it by 2. And then you can solve each equation. So your equation, again, is going to be -7 plus x equals -6, which means x equals, add 7 to both sides, x equals 1.
Okay.
And then -3 plus y over 2 equals 5. -3 plus y equals 10. I'm multiplying both sides by 2. Y equals 13. Is this the answer key?
Yeah, that's the answer that she had.
How did she get -1? Did I write something wrong here?
And she got -113.
Oh, because I'm an idiot. What's 4 times 6? What's 4 times 2?
4 times 2, 8.
It's 8. I wrote 6. Now when I add 7, I get negative. So your x coordinate is -1, your y coordinate is 13.
Okay.
Got it?
Yep.
Find x.
These are the ones that I get really confused on.
Okay, so for this one, 140 is this. So you know these. So you know that these two are going to have to add up to 40, right? So let's write variables here. Let's call that x, and let's call that y. Okay. Now these ones we know are equal to each other, right? We also know these ones are equal to each other, right? Oh, but I shouldn't call it x because we already have an x up here. So let's call it z.
Okay.
Okay, we'll call that z, and we'll call that z. So let's write some equations. First of all, what do we know about this triangle right here? What do those have to add up to?
180.
That's right. So 140 plus z plus y has to equal what?
180.
180, which means z plus y has to equal
40.
40. So there's one equation. And another equation is going to be that let's see. We know that what else do we know?
We know that x plus 2z plus 2y equals 180.
Right, but that is true, but that's only one. We know x plus 2z plus 2y equals 180. But I need 3 equations if I have 3 variables. Unless, wait a minute, unless I can substitute in, which I'm going to be able to do here. So let's do this. Let's rewrite this as 2z plus 2y, and let's subtract the x from both sides. And now let's take a 2 out. See how I'm factoring a 2 out? The reason I'm doing that is because what does this equal right here?
It equals 40.
Yeah, that equals 40, right? So now I'm going to plug 40 into here. And now I can solve this for x. So multiply both sides by 2, you get 80. 180 minus x. Let's subtract 180 from both sides. So that's -100 equals -x. So x equals 100. So I found out what x equals. And now I can find out what the other things equal.
If we needed to, but we just needed to find x.
Actually, I don't even know if I can find out what the other things equal because they just said find x.
Yeah.
I don't know that I could find z and y because I just know that they have to add up to 40, but there's no relationship between them. That's why this was a tricky question. This was a tricky one because they weren't really trying to solve for all 3 variables. They were just trying to solve for x. Okay. So this was a little bit different than a standard system of equations problem. Got it?
Yep.
Okay, find or given that, find x. So you know that LU and NU are equal to each other. LU and NU. So this is equal to this. Okay, that means this full angle is equal to this full angle, right?
Yeah.
And where is x? They want us to find just this little angle right here.
Yes.
Okay. So so do you see these smaller triangles right here? You can see that those are right angles. Did they give us that these are right angles?
Yes.
Did they give us that? Or they gave us this right angle? Okay. So if that's a right angle, then I know that, and this is a right angle. That means this is, which means I have hypotenuse. Do I have hypotenuse leg? Do I have hypotenuse leg? No, they only gave us one side was equal, but they also gave us, do they share a leg? No, I don't think they do. I'm trying to see if these two triangles are congruent to each other. Because I have the fact that they're right angles. And I also have, oh, wait a minute. Yeah, maybe because they share this angle too. So yeah, the angle, side angle. Angle, because of the right triangle, because this is a right angle here, and that's 40, then I know that this angle here, erase that. I know that this angle here has to be 50. That has to be 50 degrees.
How do you know it's 50?
And so does this one right here. Because this triangle right here is a right triangle.
Okay.
See that triangle? That's a right triangle, so that's 90. So these two have to add up to 90. This angle and that angle have to add up to 90.
Okay.
So that has to be 50. Likewise here, that has to be 50. Does that make sense?
Yep.
Okay, and then if this is 40 and if these two are equal to each other, then these big angles have to be equal to each other like we talked about. Right? So what's 40? 40 plus those plus 2 times what equals 180. Right? Because the three angles have to all add up to 180. So 40 and whatever this one is and this one, which are the same, right? Because it's a isosceles triangle. So I'm calling that 2. I shouldn't call it x because x is something else. Let's call it y. This big angle here is y. And so is this big angle. So 2y equals 140, which means y equals 70. So this whole angle equals 70 right here. Then tell me what this small angle equals right here. That's small x.
20. Because
exactly. Yep. So that equals 20.
Okay.
Okay. That was a tricky one to look at because there were so many lines and angles. All right. FT is a median of DFE. Okay. Find the coordinates of T. Oh, classic. All right. So if it's okay. So you know that this being a median means that it's, if I were to draw a line here, that point right there is 2B, right? You can see how they have it there, 2B. And if and so this is 1b. You see how they have that written like that? And
Mm-hmm.
likewise, if I were to drop a line straight down here, this is A. I'm sorry, this is 2A because this is 1A. That's why they wrote what they wrote there for you. So find the coordinates of, I'm trying to think of what they want you to say. Find the coordinates of T. Is it just A and B?
I think so.
Is that all they wanted you to write? Just A and B?
Mm-hmm. But
I
if it
mean,
was
that
like,
is what,
but if it was like more complicated, like
yeah,
more abstract numbers.
right, right. But do you understand why? Do you understand that they actually made it kind of easy for you by telling you that E is 2A and 2A comma 2B. So if you take this point like I did here, and you drop it down and you drop it over, there's your 2B, there's your Y, and there's your 2A, there's your X. And since it's a midpoint, since this is a midpoint, since T is a midpoint, it's just halfway between there and right. This would have been 0. Remember the midpoint formula?
Mm-hmm.
The midpoint formula, since it's centered at 0, that's what makes it easy as well. You say you add them together, 2A plus 0 over 2, 2B plus 0 over 2, and that's your midpoint,
And that would just
which
come
is
out. to
just A
A.
over B. Yep.
Okay.
So if they had it in a different place, if they didn't have this centered at 0, you'd have to put a different value here.
Okay.
That makes sense?
Mm-hmm.
All right. Hopefully that helps. And hopefully you crush that quiz tomorrow.